Our first presentation today is on alarm automation for predictive maintenance. And we're joined by a company called KCF Technologies and two people from KCF, as well as Jason Vox, a regional sales manager here at Blue Mountain. But we're joined by Ben Lawrence, who's the Chief Business Officer at KCF Technologies, and he'll be giving a little bit of background on KCF so you can understand what they do there. And then we're joined by Levi Howman, who's a manager of Pharmaceutical Century at KCF Technology. So welcome, Ben and Levi and Jason. And I will stop sharing so that you can share your screen.
Thanks, Drexel. Give Levi a second here to share his screen. He's gonna drive the PowerPoint for us today.
All right, we should be live.
All right, awesome. Well, thank you everyone for attending day 2 of the summit. I know day 1 was packed full of amazing content. You know, Scott and Paul and all of the presenters did a great job. Drexel and Savannah really, set us up and took care of, a pretty new format for us and new technology. So I know that, we're going to build off of that today and start with some pretty exciting content. So I'm here today to present alarm automation and predictive maintenance, along with our esteemed colleagues, Ben and Levi from KCF Technologies. So I'm going to kind of get us kicked off here, and we're going to talk a little bit about the different types of maintenance that we deal with on a regular basis. Levi, there we go. So essentially, we've really got 3 different types of maintenance that we deal with on a day-to-day basis. The facilities team members, the maintenance team members, and the reliability engineers are all going to be very familiar with this. We have reactive, we have preventative, and we have predictive. We're going to spend a little bit of time today, and we're going to kind of talk about some of the limitations that come with reactive and preventative type maintenances. And then we're going to talk a little bit about the benefits of predictive type maintenance. So as we go through this, feel free to ask questions, and we'll do the best we can to answer them. So the first thing we're going to look at is a reactive type maintenance. Most of us know this as either corrective or demand, and some of that is based on industry language, and others are based on how the Blue Mountain RAM application defines it. In our case, demand is the term we use. This is currently the most common process for this is a very manual process. From the identification of it all the way through the work request generation. Blue Mountain RAM offers a fantastic way to capture these in a 21 CFR Part 11 compliant system. We see, we hear, we smell something. We go over to the application and we click the add request button. Obviously, there's many ways to do it, and I'm simplifying this for today's purposes. But once we click that add request, we have the ability to capture the information, capture the asset that's under observation. We have the ability to create a submission comments, things like that. And then we can go straight into manual creation of demand work. Most of us know the options there because we're mostly RAM users here, but you can create a strictly demand work that you have to plan and create on your own. We can create an on-demand event-based work that actually has some of the steps and planning done for us, but it's a very manual process. And with reactive maintenance, we have certain issues that are involved. It can leave critical equipment down at the worst possible time. It can create, technician planning is almost impossible with this type of maintenance because we're reacting to a problem that's coming in. And then there's always the problem of waiting for parts. So when we have to react to this, we're waiting for parts to come in. And that can create extended downtime, which obviously is not good whenever we're in the manufacturing business and we make money off of the things we manufacture. So we try to minimize this type of work by performing preventative maintenance and other types of maintenance. This is kind of the last resort. Next slide, Levi. So the next thing we're going to take a look at is preventative maintenance. This is seen as a better option than corrective, demand, or as we're calling it today, reactive, because it is truly reactive to what's happening in front of us. Most of the time we're seeing planning based on manufacturers' recommendations, whether it's a daily, a weekly, or a monthly type activity, whether it's cleaning, lubricating, replacing wear parts. These are all necessary things in our industry because we're a validated industry. We are, GMP, GXP. We have to do this type of thing, and we have to show proof of it. So we use Blue Mountain RAM for scheduling. We use Blue Mountain RAM to track those work records from beginning to end. And then we use Blue Mountain RAM to track the work histories as well as the audit trails that go along with them. So again, preventative is certainly better than demand or reactive. But there are times where we're able to kind of mix that preventative in with predictive and make it even better. So when we look at the ability to kind of check histories, work histories, and create new maintenance schedules, maybe something has a good work history and things like that. Sometimes we have the ability to extend those periods of time, which is a kind of a hybrid or mixture of preventative and predictive. Again, preventative is a necessary component to keeping our equipment running smoothly and minimizing reactive maintenance and downtime. So a couple of common problems that we see, and the first one, difficult to find the problems, is more defined and related to the reactive type of maintenance. It's really limited to human senses like sight, smell, and sound. And the problem is that it really promotes last minute findings and difficult planning. We want to eliminate that and really do better than that. The next may produce unnecessary work. So with preventative maintenance, we may be working on the wrong thing, or we may be changing a part weekly that would last a year or more. So it does have a tendency to produce unnecessary work, even though it's necessary to do our regular maintenance. The last area here is that it's hard to know if the issue is corrected. Both reactive and preventative fall within this category. Again, it's somewhat limited to just human senses. Did the sound go away? Did the smell go away? Or did the vibration go away? Those are our indicators to let us know whether or not the work we did solved the problem. We never really know if we fixed the right problem or if we fixed the problem completely. So the next slide, Levi. So the what ifs, this is kind of future thinking. What if you had an early warning indicator, which would allow for advanced planning, technician scheduling, or parts ordering? What if you could see the problem developing rather than a human noticeable indicator such as sight, smell, or sound? What if you could see the problem developing long before it came about? What if you could see proof of correction? After you think the problem is fixed, you really would like to verify it. So if we kind of look at these what ifs and we had a system that really kind of tied itself to these what ifs, it would be a fantastic story to tell, to have a early warning indicator, to know that problem is coming about, and to know that we fixed the problem once we've identified and worked through it. Next slide. So with that, we've been collaborating with KCF Technology since just after Summit 2018. One of our common customers happened to be in town for the summit that year, and they walked down Beaver Avenue right past one of the KCF offices, and they started the conversation with us right there at the summit, and they saw the benefits of integrating these two applications and automating their alarm management. So what I'd like to do now is introduce you to these two gentlemen. They're going to walk you through the process that turns those what ifs into reality. So with great excitement that I turn you over to Ben and Levi so that they can detail how the future of predictive maintenance is now.
Terrific. Thank you, Jason. This is Ben Lawrence. I'm here with Levi. And just a quick audio check. How's my audio coming through for you guys?
Sounds good.
All right. Terrific. So, Jason, thanks for that introduction. Levi and I have been so excited to connect with and learn more about your customers in pharmaceutical. We service the pharmaceutical industry in addition to many others. But what we see again and again in pharmaceutical, I mean, my heart bleeds for those who work in pharmaceutical manufacturing plants, because we see again and again that you guys are under tremendous pressure to maintain uptime in your plants, often at all costs. And what's really interesting, before we even talk about my company, Jason, is there are two reasons we find pharmaceutical manufacturing plants face more pressure than nearly any other industry. Number one is because you guys are so held to compliance. As a matter of fact, of all the industries that our company services, and they're all listed here, I mean, we're all over the place in the United States, there's only one industry that we service that we find is more heavily regulated on the maintenance side than yours. And if we were all in the same room, I could ask you to shout out what you think that is. I know that's hard on Zoom. So I guess I'll give you the answer. But the only industry we find that's more heavily regulated on the maintenance side than pharmaceutical is nuclear power. So yes, it seems the government is really concerned about a nuclear meltdown, and they're nearly as concerned about you guys missing your deliveries on mission-critical, life-giving drugs. Second is, the other thing we look at is the cost of your industry's downtime. And of all the industries we service, your cost of downtime is number 2 most expensive. Jason, since you're unmuted, what do you think is the number 1 most costly downtime industry that we service?
I would guess automotive, but I could be wrong.
Oh my gosh, you need to go on Jeopardy. Yes, it's automotive, and specifically, it is American-based pickup truck factories. So if anybody on this call right now drives a Ford F-150 pickup, that is the number 1 most costly downtime plant that we service. Their cost of downtime is $15,000 a minute. But the number 2, take out steel, take out oil and gas, take out the paper industry, pharmaceutical has the second highest cost of downtime. So you sum all that up, and what that means is, I would not be surprised if 50% of the people on this call right now have like a bottle of Maalox right next to their phone, because the pressure is tremendous, and we recognize that. And as we continue to race toward, warp speed COVID vaccines, I don't have any doubt that you guys are going to feel more pressure than ever. So we recognize that, and we appreciate what you guys are doing. Just a little bit about our company. Ironically enough, we're actually headquartered about a mile down the road from Blue Mountain's headquarters. We're right here in State College. So a little bit of interesting trivia. Last we checked, we're actually the second fastest growing technology device company in the country, behind Fitbit. So Fitbit sells more sensors than we do, but we come in second. And our company is focused exclusively on the industrial world. So what our company does in a nutshell is that we sell and service Fitbits for industrial machines. So little wireless, completely wireless sensors that are magnetically mounted. It takes about 10 seconds to install. And those sensors, once they're mounted onto your machine, they're listening through primarily vibration and temperature, but we also get into oil pressure and oil quality and all these other things. But primarily vibration and temperature continuous readings on that machine that will immediately notify us and notify you when those machines are beginning to show signs of being sick, signs that they need to be serviced. And that simple tool gives you the opportunity. If you fast forward, what's the benefit? Why should you care? Well, two reasons you should care. Number one, when you have the right technology on your critical assets, what we find with others in your industry is that 80% of your unplanned downtime associated with mechanical failures goes away. Second is the amount of lost product. Think about pharmaceutical batches that you have to throw out because the air quality in the room was not good enough. And we're going to talk about that. You lose a lot less product than you used to. So those are the primary benefits. It's what our company offers. Much like Blue Mountain, this is also to your benefit. We do not report to Wall Street. We do not have outside investors. We do not have to worry about quarterly earnings reports. The only customer we serve is you. And I think it's one of the big advantages that you have in working with companies like Blue Mountain or KCF is either you win and pay us money because you won, or we go out of business. There's no Silicon Valley angel investor that's going to bail us out. Right, Levi?
That's right.
Okay. All right, so let's go to the next slide. All right, so we have for the last couple of years been working with pharmaceutical companies across the US, including Blue Mountain customers. And through these projects that we have done in partnership with Blue Mountain, there's good news and there's bad news, okay? The good news is by instrumenting your critical assets with these little wireless devices, your industry is seeing real benefits in eliminating downtime and getting a big return on every dollar that you invest in these partnerships. As a matter of fact, in your industry, and this is conservative, every dollar that you invest in a partnership like this, you, the customer, you should be documenting at least $10 in return. Or you're either we're not doing something right or you're not doing something right. And we can talk about that if you have questions about what separates the winners from the losers. It's not part of our formal presentation, but it's a critical piece. But the bad news is, what we heard from our customers is as much as they appreciated our technology and our services, we were living in an entirely separate software interface, a separate dashboard. So you had your Blue Mountain interface, your CMMS, or where you manage your maintenance program, and that's one dashboard. And then you had KCF's system on another dashboard, and the two did not merge. So because of that, put yourself in the shoes of an overworked maintenance or reliability professional. It's all you can do to keep up with your machine maintenance interface, let alone a machine health monitoring interface. So we knew this was a problem that was important for us to address. And for anyone on the call who's ever been involved with technology integration, like typically when you hear technology integration, run for the hills because you know it's going to be a pain. It's going to cost a lot of money. It's like building a house. It costs way more than the contractor ever told you, and it takes a lot longer, and you're going to have a lot of fights along the way. Fortunately, Blue Mountain, they're fast, they're agile, they're right up the street from our company. So we were able to build an integration solution for your industry that I am absolutely positive is fastest to market for pharmaceutical. And that's what we're going to be introducing to you guys today. And I think with that, Levi, oh, okay, I guess I talked to this and then you're the next one.
Yeah, go for it.
All right. Just to summarize it, guys, we talked about the two separate dashboards. The old way, the original way, that we were working with pharmaceutical manufacturing companies, including some on the line with us today, I believe, is that our sensors would trigger machine health alarms, notices that your maintenance team had to go fix something before it caused unplanned downtime. At that point, our friend Levi, who's on the call right now, he would be picking up the phone, emailing, sending smoke signals. I mean, whatever it took to just get the maintenance team at the manufacturing facility to drop all their other work and pay attention to Levi via a separate interface. Big pain in the butt. It took 2 to 3 days just to close the loop on those machine health notifications. So post-integration, since we've gone through this surprisingly fast, friendly, and easy exercise of integrating with Blue Mountain, instead of a 2 to 3 day turnaround, your maintenance team is now getting immediate notification via one interface, which is your Blue Mountain interface. And we're finding that the turnaround and the action that your maintenance team is able to take is way faster. I mean, we're down to minutes or hours compared to days or weeks. So it really is an extraordinary story that benefits you, the customer, and that's what Levi is prepared to share with you.
Absolutely. So excuse this, I'm going to slide over here. So thanks, Ben, for setting that up. And I think that, you hit it on the head when we're talking about actionable data and simple data and information that works for us and not that we have to work to figure out. And that's the whole heart of this integration and what we're working with Blue Mountain to do. So I want to walk through with you guys just a brief overview of how this relationship is going to work. Smart Diagnostics is our software. BM RAM is Blue Mountain software, obviously, that you guys are very familiar with. But as Ben mentioned, we've got these sensors, implemented on these critical assets in pharmaceutical facilities. And when one of these sensors triggers an alarm, traditionally what happens is it triggers my attention as an engineer for review. But with this integration, what I'm now able to do is validate that issue as a significant health condition that needs to be addressed, and then send that request from our software directly into BM RAM. So no longer are there manual interactions where I call a customer and say, hey, this is the asset we're concerned with. Can you create a request on this asset to get work done? It eliminates that degree of filtering through maybe a management personnel or a site champion directly to the guys that are going to be doing that work. And the cool thing is, you'll notice some of these dotted lines coming back over. It's going to document those actions on these work requests or work orders back to my software as well, and back to Smart Diagnostics, so that our engineers that are servicing your assets can be on the same page. We can see the life cycle of some of these flows. But after this step, it's like everything you've ever done in Blue Mountain as far as processing work requests and work orders go. You'll see, okay, now we're going to create that work order, and we'll get a notification that that work order was created. Moving forward, one of your professionals is going to perform a corrective maintenance on the asset that we've identified and then close out that work order. From there, we'll get a notification that it was closed. And here's the really critical part. As Jason mentioned earlier, our data should confirm that that closed work order represents a healthy asset, right? We need to be able to confirm the data behind the action did indeed improve the health of the asset. And so I'm excited to kind of jump into a bit of an example here. We're going to go live into our softwares and show you what this interaction would look like. So for those of you that aren't familiar, you're looking at Smart Diagnostics here. This top trend line here is the vibration of an asset over time. And so just immediately off the bat, we can see our warning and alarm thresholds. We can see something happened here around 7 p.m. that threw this asset into a higher level of vibration. So me as an engineer, I'm going to dive into the data and confirm, oh, look, we saw this jump here. This may be indicative of an imbalance condition on this asset. I'm going to want to let my customer know as soon as I can. And so I'm going to click through, and now I have the ability to send a work order or a work request on this asset specifically. So I, as the engineer, I'm going to send that. And what you are going to see as a Blue Mountain customer is this is going to come into your request as any other request would. And so just sort of the specifics of how this is going to go, we're going to click into the queries, we're going to drop down our request, and we're going to see a new section here for smart diagnostics alarms. When we click here, we're going to see these request numbers are denoted by an SD, making it clear they're coming from smart diagnostics. And so we can see this one just came in. When I click on this alarm, or this request rather, what I'm going to see is the unit or the asset in question based on your asset IDs that you're used to seeing in Blue Mountain. In the details page, we're going to see which sensor, right? This is the motor inboard on this asset. We're going to see which indicator through the alarm and what the value of that indicator is. And a really cool thing here, we're going to see a link back to Smart Diagnostics. So you can click this hyperlink and it's going to take you right to the data that shows that alarm was triggered. Additionally, we'll be able to fill comments in and give you what our initial diagnosis of the issue would be, and you'll be able to see that in the request. For the sake of the example, let's go ahead and process this as a regular request, right? So we're going to approve this request, and then we're going to add and attach work, creating that work order. So this is going to be on demand. It's going to be a maintenance action. Non-GMP is fine, and we're moving through, bam. We've just created the work order. And like I said earlier, our engineers are going to get the notification that that was created. We know that we're on the same page before even making a phone call. From there, this work order, I'm going to kind of summarize some of this because you guys are much more familiar at it than even I am. We can assign this to a specific technician, all the same things that you're used to seeing. So if we update this status, say they perform the maintenance action and it's going to management review. From there, they confirm that they're happy with the way that work order was processed, the way that maintenance was. We're going to close the work order. Hoorah, we've done it. Now that's where it ends traditionally. For you guys, this is where the process stops and you go back to production. But that's not good enough for us at KCF. We want to see and have data to back that maintenance action to prove that the asset did indeed get healthier. And so what we would expect to see is something like this, right? Looking at the life cycle of this type of asset, here's where we called it out as it jumped here, right? 7 p.m. And we look and we see, okay, this request was approved that I sent over. And then I can see you did open a work order for it. I expected that downtime here to correct the condition of the asset. We see the work order closed. We can confirm, if we look at the condition as it developed, we can see here in the spectrum, and this is obviously in-depth vibration stuff that's not really relevant, but we can see the level of this at the highest point. And after it's corrected, we should expect to see that drop way down. And there it is. And this is the kind of thing we can put behind these maintenance actions to prove that the action we took did indeed correct and improve the health of the asset. So coming back over here, and let me just get rid of some of these windows. Ben and I think we can have more of a discussion now on what the major benefits of a system like this would be. It's pretty clear when, as Ben mentioned before, when we can identify these issues developing, when we can see them way before they cause a process interruption or any potential issue, we have the ability to reduce a lot of unplanned downtime. Ben threw the number out that the average we see is 80%. We should be hoping and expecting a minimum of 60%. If we don't, then we need to work on that. We need to refocus and push from there. Another major thing is to liberate your maintenance team, looking at and identifying maybe some maintenance action that doesn't actually improve the health of that equipment, or maybe even it negatively affects the health of that equipment. We found that a lot of times, and putting data behind that gives us the ability to identify those things and eliminate them. And then, that final one is just extending the life of your assets, right? If we are, you think about your car, if we're changing the oil, if we're identifying these actions that we can take to extend the life before it explodes and we have to put a new engine in it, that is going to drastically improve the quality and the function of your maintenance programs. All right. There we go. So Ben, you want to talk about the 3 key takeaways for these guys?
Yeah, you can just bring them up on the slide. So guys, the number one takeaway is probably the middle one. We talk about these cool little vibration sensors, these Fitbits we put on machines. And what we often find when we start meeting with companies is that they get really excited about the technology. Ooh, look at this sensor. This is so cool. I can monitor vibration and catch failures. That's true. But the sensors alone, we have found this again and again. If there's one takeaway, it's if you buy this type of continuous monitoring technology and you do not have the right culture or the right leadership in place to really blend this into the way that you tackle your maintenance challenges, it could be the biggest waste of money that you have invested in a long time. So we joke, it's not about the technology, it's not about the sensor. It's really a question when you look in the mirror to say, is my team ready to go from reactive maintenance or time-based maintenance to predictive? Are they ready to be proactive in the way they do their work? And we often say, well, of course, who wouldn't be? Well, we're humans. We don't like to change. The difference between the companies that have really succeeded with this program and the ones who have not is really just how open are they to trusting the data and addressing maintenance in a completely different way. That's the number one takeaway. Second is the whole concept of putting these sensors on your critical assets, fans and blowers. We could talk about fans and blowers for the next 3 months, right, Levi?
Absolutely.
Those especially. But in pharmaceutical manufacturing, if you're anything like what we have seen in automotive, in steel, in oil and gas, in paper, this technology is here to stay. Our prediction and what we see based on other industries that we service is within the next 5 years, minimum 90% of your critical assets are going to have a sensor on them. It may not be ours, it may be somebody else's, but this is coming. And the third takeaway, what we really learned is that when you're looking for the right solution, insist on out-of-the-box day one integration with your CMMS. Whether it's Blue Mountain, who's already cracked the code on how to do this, or if you're not yet a Blue Mountain customer or you're thinking about it, I would be looking very carefully at to what extent that system is nicely and firmly integrated in a way that's going to make your maintenance team's work easier and not more complicated. And I think, is that the end of our slides, Levi? I believe so.
Yeah, that's what we have.
Yeah.
I think we can wrap it up and open it up.
That's a good segue. That's a good segue, Ben. So thank you for that. We didn't practice that, by the way. Blue Mountain and KCF have actually been working together now for about 2 years, trying to kind of put this together. I know Jim knows Jeremy with KCF, the two owners of the company. So, it's a little bit of a unique dynamic there where we're so personally connected as well as professionally. But what we've essentially been able to do is build out that integration where we can leverage that template for other customers. So now we have that capability for not so much of a custom integration, but at least a templatized thing where we have a starting point. The requirements from a Blue Mountain standpoint are relatively minimal. We have to create a new work request type. The old-fashioned manual request didn't quite capture the right data to be able to kind of send information back and forth. So we configure a new work request type. So as Jeremy showed in the one query where Smart Diagnostics had their own work requests, it had an alarm details tab. In most cases, we don't have that tab on our best practices template or most of our customers' custom configuration. So we configure that component, but it's very minimal what we need to do to get you started with this type of a technology, as long as you're willing to go along with the same template that we've started with. So Blue Mountain has acknowledged the need to the Internet of Things. Jim talks a lot about the Internet of Things. IOTT, IITT. I forget what all the acronym stands for there, but we're trying to help you predict it and see that information quicker. We collaborated with our friends here at KCF, and I think we've really put together a good connection, a good interface between the two. With that, Savannah, do you want me to read the questions, or do you want to read the questions?
I'll jump in there, Jason. I can help kind of filter through them. Okay. So you got a number of questions here to go, and I'm just going to start at the top of the chat list. And if you ask one of these questions, feel free to chime in if we need a little bit more detail around it. But the first question here is from a regulatory perspective: who owns or performs trending on alarms? And the second part of that statement is quality folks may want this information as part of investigations or deviations.
Yes. So thank you. And that was Peter Murray, I see, who also answered the regulatory question. He guessed nuclear. So Peter, you're on it, man. So I guess I'll go back and say there are two pieces to your question. The first is who owns the data? Who's able to trend it, look at it, do deeper dive analysis? You, the customer. So I'm really glad you asked, because you will find that there are companies like ours where they own the data. You're allowed to look at it, but only through their software interface. In these cases, you own it, and your team has full access to go back and do autopsies, if you will, but post-game analysis or root cause analysis on what caused the failure in the first place. As far as who is setting the alarms or making sure that the alarms are set at the appropriate levels, we offer that service. So here at KCF, I mean, if we just think about the critical assets in a pharmaceutical manufacturing facility, for example, exhausts and blower fans, which we can touch upon, we set those alarms because we've been trending literally thousands of those assets across your industry and other industries for years. So the amount of baseline data we have on what a healthy exhaust fan should be looking like versus an unhealthy one, we have incredibly accurate alarms. But if you have your own opinions or ideas, or the OEM has ideas that they want to share with you on how to properly set those alarm thresholds, we can change it. It's easy to do.
Yeah, and Peter, that's a good question, and I think there's some perspective there that we want to take a look at. For time's sake, what I'd like to do is maybe kind of take that into one of our networking sessions at the end of the day, because I think there's some perspective that you can give Ben on what your question is. So sure. If you're okay with that, we'll just kind of take that.
Yeah. All right, there's a couple more, but yeah, sure. Save for later.
Thanks. I'm going to keep going through these questions here, and we can kind of add to them or take ones offline that we need to. But the next question here asks about 21 CFR Part 11. Is asking if Smart Diagnostics is 21 CFR Part 11 compliant.
I'm interested to know, that comes from Leonidas. I hope I'm saying that right. Can you give us a little more context on why you ask, or what you have in mind that's driving that?
Yeah, good morning. So first of all, exciting technology. Thank you for presenting that. So my question was regarding smart diagnostics, right? We're going to be able to log in, see the trend, and most likely there are going to be some actions there, maybe acknowledging alarms, maybe altering, maybe getting some data, etc. So that smart diagnostic systems, is it 21 CFR Part compliant? Is there full audit trail? Is it, can anybody go in and change stuff inside there? How is that protecting us from somebody unauthorized to go in and alter anything on the trends, on the alarm history, etc.? So that type of thing.
Yeah. Thank you for that question, Leonidas. We get a lot of, as a matter of fact, I would say next to the paper industry, our pharmaceutical customers are more concerned about data privacy and data security than anyone else. Levi, I'm not sure about the compliance part, but to what extent can you share how we've closed those obstacles our pharmaceutical customers?
Yeah, absolutely. So everything is going to be dedicated to the users that you identify as the ones that need to see the information. As part of a relationship with our company, there's a select few individuals, whether that's your management, your maintenance guys, yourself, and the engineer from the KCF's team that is going to have access to those things. And those things are set, based on ISO standards, based on the asset's health itself. So it's not, it wouldn't be possible for somebody external to that system, to that closed loop, to come in and to make those changes. And we have a lot of, secure infrastructure in place to prevent those sort of things from happening.
And I think just to kind of add on to that quickly, what you're replacing is a human response with an automated response. The quality system, the checks and balances on the back end are going to be once the work request is submitted. We go into the Part 11 compliant RAM system. We identify the problem. We create whatever approvals are required based on your quality processes and things like that. So essentially, is it irrelevant? No, but the critical Part 11 compliance factors come once that request is into the RAM application and follows your quality processes.
Right.
So just a quick chime in. I think the only reason that I would want to be concerned if it was CFR compliant would be if I was looking to replace my continuous environmental monitoring system with this. I don't see it as that. I see it more as a tool to monitor my equipment and predictive preventive maintenance type work and automating it with Blue Mountain.
Yeah, Chris, this is Jordan. Just to elaborate on what you're talking about. So we have KCF Smart Diagnostics. We've had it installed at our site, and we are actually the ones working with them and Blue Mountain to have the integration made possible, and super excited about this presentation. So the way we see it is it is a business tool, and we see it as basically an extra ear, an extra eye on the health of the asset that we are monitoring. And so because the data is being pushed out to KCF, we are not considering this to be needing to be a validated system. So, or needing to be compliant necessarily with 21 CFR. Again, it's just it's a business tool. It's not affecting how we make decisions. It's just putting a request out there, and it's letting us decide what we want to do with that request. We could reject the request. We could accept the request, turn it into a work order. And to Jason's point, once it's converted to once the request is converted to a work order in Blue Mountain, and Blue Mountain's our validated system, that's what we're going to use to be able to, as far as the validated system we're going to use, and what quality is going to look at when they're assessing the work that we completed. So as far as it goes, we are, there are some aspects, of course. So if there's changes that we're making to Blue Mountain to accept the workflow, this new workflow of work requests, yes, that is a change to Blue Mountain that we'll need to validate, that we'll need to test and get QA buy-in. But as far as the data goes, this is, for us, the way we see it and the way we pitched it to our quality department has been to simply be an extra ear and eye on the asset. And the technology itself does not change the performance of the asset. All it's doing is getting information from the asset. So that's kind of where we stand. And I'd be happy to answer more questions regarding how we decided to approach this integration and how we worked through with our QA department on this, because it was an ongoing discussion.
And something to add to that, and I don't know if you guys do this there, Jordan, but these could be devices that you may put a small tag on that says for informational use only, so that if there was a plant walkthrough with the FDA, they would know that that's not a GMP calibrated equipment or anything like that, that we're just using it for information, and we're not really basing any of the preventative maintenance schedule or the calibration schedule on that. And that usually covers things as long as you have it documented like that.
Yeah, as well, Jimmy, as I try not to tag the instruments as much as if it's in Blue Mountain and it's labeled as GXP or critical. That's the system of record, because tags fall off, and I've had that happen to me during an audit, and they're saying, well, that one's tagged, why isn't that one? So I try to go the other place to just say, here's my list. If it's not on that list, then it's not part of that.
Yeah, those are good questions. I'm going to try to combine a couple of these just in the effort of keeping us somewhat on time here today. So, and maybe Ben or Levi could talk a little bit more broadly about the sensors, but the series of ones I want to combine here is, what types of sensors do you have? Can you use existing sensors to communicate with smart diagnostics? Yeah, so I think that's probably a good starting place here.
Sure. Yeah, I can touch on a few of those things. So as Ben mentioned, the sensors themselves all play into an understanding of the health of the asset. And so when we look across a potential sensors, I would say 90 to 95% of our customers are utilizing primarily vibration and temperature sensors because they give you the indication of the health of the asset. When we see elevated vibration condition, or rather when we see a change in the condition of the asset, that's going to be manifested in a specific vibration content or a specific signature. And that's what our engineers are trained to identify and to work with your guys on. But to answer the other question, yes, we can. We utilize what we call a general input sensor node that can tie into any existing pressure or temperature or vibration sensors that may be there. Because again, the focus is to have a holistic understanding of the health of the asset more than to be a sensor vendor for you guys, as Ben mentioned.
Yeah, and along that same
Levi,
line,
I'm going to add to that. So if you need for your existing sensor network, if you need to transmit all that data wirelessly, then you can hook on a connector that we offer and just send it that way. We have customers, we're very familiar with this. There's a REST API. So all the data that we're trending in our software, you can export immediately into your own data historian to do root cause analysis or higher level trending in that software package. Or the API works the other way. So if you have other sensors that are already sending data to other systems, the data can come directly into our software and trend in there right along with the other data points that we're already picking up. So Drexel, I hope that clarifies the question. It's an important one. And yes, it is class 1 div 2 is the other, someone had asked that. So the sensors themselves are class 1 div 2.
Yeah, thank you. Lots of great questions. I know I'm certain Ben and Levi, your contact information is in our networking list. So, definitely, and Jason Box too, if you have questions for them, we can definitely take those offline or continued questions about smart diagnostics and the integration. Thank you guys.
Just to close up, I know we're short on time. Jordan and Brian, hello guys at PAR. I see you're both on the call. They really are among your industry's trailblazers when it comes to how to effectively blend continuous machine health monitoring and predictive maintenance into a pharmaceutical program. You're welcome to contact Levi and me, but boy, I'll tell you, Jordan and Brian are treasures. They are resources that I hope all of your other customers are able to network with tonight during that session.